Hello everybody, welcome to the new video. Now, if you go to my website, you'll see I have organized my projects into 4 different categories. First category is for my personal programming projects, second one is for now defunct original Go, third one is for bigger, and fourth one is for non-programming projects. Currently I have 4 open projects, 2 of them are full programming projects, Jamisa and Teralisa, and they're on pause. They're on pause because currently I like interdisciplinarity more and work on some interdisciplinary projects where programming is a small cut, and I like science more than engineering. These 2 projects are Bigger and another project. Bigger is actually going pretty well. It is about 45% done. We have assembled main box and have finished front end besides image and GIS extract. Rest of components have been designed, and once we assemble them, we will finish backend, solder all the components, and do interesting project with Big. This another project is also going pretty well. Today we are going to review my personal programming projects. It's going to be a high-level overview. I have made reviews. Termin Peli, WinGOS is really too archaic for any further analysis. Bigger reviews will come as project progresses, and I have made a review of this non-programming project. Before we start with the video, as usual, like and subscribe, and also start these projects on GitHub. First project on the list is FreeX. It is a very simple program which is designed to play with Collat's conjecture. So what is Collat's conjecture? It says that if you have a number, if number is odd, you multiply by 3 and then 1, and if number is even, you divide by 2, and eventually you will come to the 4-2-1 loop. Now again, this is a very simple program. It uses very simple multiplication algorithms. You could use more advanced multiplication algorithms like those interesting graphs where you compare how your code is efficient, but I'm not doing this here. I'm using new GMP library in order to handle very big numbers. So here check the arguments, here I initialize the numbers, I assign the value to the numbers, and this is like the main loop where I'm comparing it, is it divisible by 2, and then I'm just dividing by 2. If it is not, then I'm multiplying by 3 and adding 1, and I'm also checking for the maximum number, keeping track of a maximum number if user wants that feature, and I free the numbers. All of these programs have been run with Vanguard, so there are no memory leaks. Main, and here you can see that this program works. Again, as I said, it's going to be high level overview, nothing too complicated. This is game of Google. In this game you have X number of cards, and each card has a number, and you have to find a card with the largest number, but the trick is you cannot retroactively choose a previous card. So you're iterating through cards, and at every card you're given an option to stop or to continue. You cannot go back in time, so that's the whole point of a game. But there is a strategy to win this game. For that you can check README, or you can check out Vsauce's video, or in any other material online or offline. So again, for GOG, FreeX and GOG are very simple command line programs. In GOG I'm also using GMP, the new GMP library, and here is the main function. Here I'm inputting number of cards, and I'm inputting a maximum number. I'm using so I'm just directly inputting it to Google, and here I have a num cards. Here I'm initializing an array of cards. I'm initializing the array of cards, and this is the last card ID is just here. Again, here we initialize the values. Again, we're just initializing 1. We have already initialized maximum number or Google number, and here is the main loop. Here we are asking a user, does it want to quit, and in for loops, when inputting characters, you have to add this space in order for scanf to work inside the loops. And here I'm just searching the array and trying to find the largest number, and if then we compare the largest number to last card ID to the card which user chose, and we just print lost or won, and we are here freeing all the variables because you have to free variables in C in order to prevent memory leaks, and memory leaks are not good things. This was everything from GOG. Both FreeX and GOG have makefile and CMake build systems, so you can choose what you want. This is GVPaint. It is a terminal paint application originally made by my friend on his 16-bit operating system. As you know, I like 16-bit operating systems, but I don't do them anymore. I made Pally, that was my last 16-bit operating system. Currently I'm more focused on the embedded systems, desktop applications, computational modeling, and interdisciplinary things like science. As I said in the intro, I like science more than engineering, so I do science-based projects. Again, this is a terminal application written in Rust, so it is it is a cross-platform application. Right, Rust is really good for making cross-platform applications. First time compile times not so good, but you get cross-platform application, which is a pretty good thing if you ask me. We start from main.rs. Here we are loading the current term crate, which is used for working with terminal and works on both Windows and Linux. It supports both Win32 API and POSIX API. Win30 API is used by Windows and POSIX API is used by Linux, by macOS, by BSD. And POSIX comes from Unix, and these three operating systems are kind of based on Unix. Unix is like their ancestor, and for personal computers, Windows dominates, but in servers and supercomputers, Unix base dominates. So here I'm just clearing the screen, and getting the terminal size, and creating canvas, creating some runtime variables, and things like that. Here we have a function for window, for help window and file window. Basically what I'm doing here is just checking cursor's position and comparing cursor's position to the buttons in the window, similar to like what I have done in Peli. Now this is very primitive and scalable way. The best thing to do is to implement some kind of events and listeners, and not just check positions. But it works, and they say don't touch it if it works. It's not very good life philosophy, but in programming it works. Here are just variables. Right, I like to have structs in like their header files or in separate Rust file in this case. And this is like the paint program. Here we have enums of keys, enums of colors. Here I'm reading user's character. This is cursor input, return color integer, moving cursor, remove all cursor, place new cursor, place block. Here we have close, redraw canvas functions, and here is the main paint function. This is main loop, while true loop in C language. We are fetching the key, and then we are comparing the key. If it is W, we remove all cursor, and then we place new cursor. Same thing for S, A, and D. It is file, then we open file window, or if it is key help, we open help window. Here is the erase. We place empty block. We actually place the block of the background color, and if it is quit, then we just close everything, and that's it. Or if window is open, then we close the window. Right. So yeah, that is basically that. every point is stored in a B3 map. Right, in B3 map, we have a pair of coordinates, x and y coordinates, and then another argument is color. And we can save this in form of .txt file or even as a PNG using RGB to image crate. Using image crate has our RGB to image function, and we can convert raw data to PNG. I don't have currently Rust installed on my system, so I cannot show you the program, but just download Rust yourself and compile the program. This is Kaladont. It is a South Slavic word game. So basically what you have to do, you have to say a word which begins with the last two letters of a previous word. The word cannot be made up, cannot be repeated, and must not be a name. And winner is a player who says a word ending on NT. So here we have main.c. We're going to start from the main file, and we're going to start from the main function. So here I initialize the gameplay structure on the heap because it's going to be used a lot, and network is going to be on the stack because it's not going to be used a lot. Here I'm entering a path, scanf. Actually, this could be easily, okay, this can be to 256 because indexes start from 0, so 25 characters. Last character is going to be 254, and 200 and character which index 255 is going to be terminating character, so 256 is the appropriate size here. And again, same thing, index will start from 0, so the maximum index will be 254. Here we'll type 255, and path can be 256. But okay, it's just 1 byte, it doesn't make a too huge of a difference, but you know. Here we have a start. The start function is copying, is reading data from JSON file. I'm using JSON-C library. So basically you have to initialize iterators and objects for it, and then you loop through the iterator, and you fetch the key, you fetch the value, and then you can convert the value to normal C variable, like this JSON object get string, put the JSON object structure, and you get constant char variable. So yeah, and here we load the words from the ordinary file, use fget function, size of buffer file, and buffer is word limit +1 for the terminating character, and if word is less than 3 words, if 3 letters, you're just skipping that word because it is invalid. And we push the words to the C vector, and string up actually puts our string on the heap, so we have to free those words here in cleanup, free gameplay words, and we're just accessing that word in the array. I'm going to show you code for server. This is basic TCP socket server. This is a POSIX version. This is Windows version. Not gonna lie, ChatGPT helped me with this part. So yeah. And here we have a client POSIX and client Windows. Here we have some utils functions. And we have a computer function here. I have actually went in the beginning for the min-max option. Wanted to use min-max algorithm, but you can only use min-max algorithm with zero-sum two-player games. Kaladont is not a zero-sum game, and it is not a two-player game. And so basically what computer does, it tries to find a word which ends on NT. so it can win. If cannot find, then it just returns the first possible word. And to my surprise, there are lots of words ending on NT, so for most of the time, a computer will win. So it's not very fun to play with computers because they can search through data fast, way faster than us humans can do. So this is now the gameplay function. We're going to start from gameplay entry function. So what we basically do here is that we so if network is available, we'll just wait for all the players to join, and when all players have joined, then I'm just checking what type of player is. Right, so in kaladont, 3 types of players can play at the same time: computer player, network player, and like this terminal server player. So in case of computer player, computer term will return a string, and in the case of network player, we are just we are waiting 30 seconds to get user input from that player. So here in NP, we are fetching for the gameplay current player. So only we're waiting for the current player. So if somebody else types something, it's not gonna count. Right. So here, every player has a network player structure, and this sockfd is actually player ID. Sockfd is a player's ID, and every player has it, offline or online. If it is offline, it's just going to be some mumbo jumbo, and we are not going to access it, so it can remain mumbo jumbo. And then we get the result from the gameplay function. If it is 0, then no point. 1 is just give point to the player. -1 is game finished with a point, and -2 is game finished without a point. And then if we are not going to wait for the correct word, we're going to go to the next player. And this is a gameplay function, just doing some string comparison, erasing some elements, and then broadcasting the messages if network is enabled, and that is that. Let me demonstrate this for you. And player 0 has 4 points and player 1 has 2 points. There is an extra point for kaladont, for the word kaladont. Right, I think that is that. This is Uno plus plus. It is a game very similar to Uno, but I don't claim any trademark, so don't sue me. Again, this function to read data from JSON is very similar to the kaladonts, iterators and things like that. Again, settings path can easily be 256, changes to 255, and the character with largest index will be 254 because indexes start from 0. So again, initializing this on the stack because it's not going to be used that much, and I'm initializing this on the heap because it's gonna be used much. And then go to the gameplay function. Code is again the same, TCP sockets, but the thing is that there's only online or offline mode. Either all players are online or all players are offline, because there's information to be leaked, so that's why. That's why you can only be a server or a client. You can be both server and a client. Let me remove this. Good. So I'll demonstrate this to you. Let me just switch here. Let's go false, so I can show you this. Right. So basically what you have to do, you have to type card number. So 64, we can do 5. We can do 3. Let's do all. And as you can see, our card 62. We have two of these cards, and now we have only one card. So one card got removed. It got played here. As you can see, it is a top card now. Here we have all the gameplay. Again, as in both kaladont and Uno++ and 3x and GOG, they both have make files and CMake, so choose what you want. 1006 lines of code, that's good. So yeah, this summer I have finished all of the projects. Actually, I have finished GVPaint in 2024, and in summer 2025 I have polished these 4 projects. So again, here is the gameplay. This is going to be user input. We're going to wait for the clients to join the game. Then we are going to deal the cards to players. Right, 7 cards. We're going to set the top card, and then we're going to run this while game loop. We're going to read the inputs from the players. We're going to check if deck is empty. If it's empty, we're going to regenerate the deck, and then we are going to do. I'm using do while true because I want this to get ran at least once. So network is enabled. Then we are pulling the input from that specific player, right? Current player. And if it is not, we're just gonna use scanf. So we're just comparing the string input. If it is new, then we're checking if already new. If it's not, then we just push back a card to a vector of players' cards. If it is all, just print all of the cards. Here we have some colors. So based on colors, we're printing different string. And if network is enabled, then we're going to send to that player that information. If it's discard, you can discard. Your turn, you can exit, and you can also, and here also it is going to be in. So we're just checking if then it's likely a card number, card ID. Then we're comparing the card ID. Is it something normal? Yeah, so we are basically checking if it's compatible or not. If it is compatible, then previous top card is runtime top card, and runtime top card changes to player's card. While I have previous top card, it is used somewhere in the code. There was a need for it, and then I erase the played card from the vector of players' cards, and then I perform an action with the top card, and that's it. So basically, I update the top card. I remove the card from player's vector, and I perform an action with the top card. There is an action based on the number K0, K7. There is also 7 house rules or tweaks, what I call my version. There is a +2. There is also stacking. I only like to play with +2 and +4 stacking. I don't like when you can stack all of the cards. Wild card, wild drawing. There is also doubt. There's like in newer versions they have added doubt, so you can doubt. When you play +4, you can only play it legally when you don't have that color, so you can doubt. If your doubt is correct, then that person who played illegally has to draw 4 cards. But if your doubt was not a real one and player has played their card legally, you have to draw 6 cards. So yeah, and here we have action input. We're just again pulling from the correct player. So if somebody else sends something to the message, it doesn't matter. So if they want to check their own cards, they can do it. We're just gonna pull from that player. Here we just generate the deck. Because I have a swap card, if it is enabled, of course. Random card, get value. So card of number 20, 50, 40, this is the points. Basically points. Is compatible, then the next player is taking care of overflows and the direction. This is points manager, just reading from the file. From the JSON file. Here we have swap, and then we have a gameplay which we already have discussed. This was everything for this video. I hope you have enjoyed this video. I hope you have enjoyed this project, and as usual, like and subscribe and start these projects on GitHub. See you in the next video or live stream.